Okay, here we are with some more review. Can't really review too much for your first semester exam. You've got to know quite a bit of information. So let's get right to it. This one is a particularly challenging problem. Anytime I see cumulative frequency chart, it's going to be a challenging problem for students. There are 25 randomly selected Little League baseball games recorded. So you can see here at the top, it's important to understand that there are 25 of these guys. So cumulatively, what this means, like this bar right here means that 5 of the 25 games were 4, what is that, game length, 4 innings or less. And then here, this means that 15, or about 15, of the 25 games were 5.5 innings or left. About 24 of the 25 games were 6 innings or less. About 24 of the games were 6.5 innings or less. About 25 of the games were 7 innings or less. Well, pretty much all of the games were 7 innings or less. That's how you read this table. It's very important that you understand how to read it. So the median game length is 5 innings. Well, median would be somewhere, 12.5, right across to about here. 5.5, that's not right. 5 is not right. 14 games lasted 5.5. So 5.5, if I follow that across, I would say 14 games were 5.5 or less. A lot of those games were less than 5.5 innings. So not all 14 of those games were 5.5. Majority of the games lasted 6 or more innings. 6 or more. Well, very few games lasted 6 or more. 24 of the 25 games were 6 or less. You could say, 15 of the games were 5.5 or less, but certainly not the majority were more than 6. That's the minority. The distribution of game lengths is severely skewed left. Well, this isn't really a histogram like we think of a histogram. It's a cumulative frequency chart, so we're not going to call it skewed, really. Games lasting more than 6 innings occurs the least frequently. That certainly is true. There's very little change here. 24 of the games were 6 innings or less. 25 of the games were 7 innings or less. Only one game was between 6 and 7 innings there. So that's definitely the answer there, I would say. Is the mean greater than the median? If you just know this simple trick, mean greater than the median. Let's see, when you have something that is skewed to the right, the mean gets pulled with that skew. So the median will stay very close to where it would have been. This might be the median. But the mean gets pulled with the skew. It's also the balancing point of the distribution. So mean and median would be very similar to each other on that one. Also very similar here. They're going to be pretty similar here. But these two, you can see that the median might be around here. And the mean might be closer to here. So this might be like the mean. I want something that's skewed right. This guy's skewed right. This guy's the answer because the mean has been pulled maybe over here, whereas the median might be over there. So this looks like a binomial problem before receiving the desired game. Or maybe is it, binomial or geometric. Let's see. There are 5 different games, equally distributed. A child would like to receive 1 game. What is probably the child opens 3 boxes of cereal before receiving the desired game? So you kind of look at it this way. The first 2 boxes, no game. So it doesn't work out. Doesn't work out. And yes, he gets the game he wants, right? So you just think through the probability of that happening. Well, what's the probability of not getting the game? There's 5 different games. Only one of them is the one he wants. So you might say this is 0.4, or sorry, 4 out of 5, which is 4 out of 5. It's 8/10. 4 out of 5 are the chances of getting no. And only 1 out of 5 is a chance of getting it correct. So if you multiply those together, we should have our answer here. That would be 16 over 25. oh sorry, 5 times 5 times 5 is 125. Or you can think about it this way. Let's see, 0.8 times 0.8 times 0.2. D would be the right answer. These are saying binomial. You have to have a fixed number of trials. Like if you wanted to get 1 out of 5 or 3 out of 7, something like that. But in this case, we're trying to get the first of something. So this is a geometric one. The first one is on the third pick is what we're hoping for there. So that's geometric. And 32, let's see. So a random variable has a standard deviation of 1.3. It's transformed by multiplying by 2 and then adding 5, right? So what if you transform it? So we start with a standard deviation of 1.3. And if you multiply that, that's going to multiply the standard deviation. So you get 2.6. But adding a value, a constant, to every term doesn't really change the spread of the data. So I would choose, for 32, I would choose B. It's just the idea of, if you start with data that looks kind of like this, 1, 2, 3, and I add 5 to every piece of data, the new data will be 6, 7, 8. It'll look pretty similar. It's a pretty bad drawing, but that's the idea of it, is that you're adding 5. The spread is not anymore spread out. Now multiply by 2 spreads it out. Instead of 1, 2, 3, it might be 2, 4, 6. That's more spread out by 2, but it doesn't change the spread of the data. So 33, since the probability of encountering American in practices, particular religion is 0.014 for the number of Americans who practice this religion. Okay, so we've got a probability here of 0.014 and a random sample size of 500. So this seems like, so at first I was tempted to say this is maybe a sample means problem, but sample means have to be quantitative variables, and you can see that this is do you practice a particular religion? That's not a quantitative variable there. It's kind of a yes-no question. So when you have yes-no questions, you've got to be thinking binomial here. There's a set number of trials here. Oops, binomial. Set number of trials of 500, so it's not geometric. So the formula for standard deviation for binomial is the square root of NPQ, if you remember that, NPQ. So you would multiply N is 500 times P is 0.014. Q, also called 1 minus P, is the complement of that, 1 minus 0.014, or 0.986. And if you multiply that out, I believe you get 2.627. The mean is 0.014. If you do 500 times 0.014, I wonder what that would be. Let me try that. So if you use your calculator to, by the way, if you don't remember that formula, the mean is equal to n times p for binomial. N times p is really bad p. So 500 times 0.014 is 7, so it's, it's one of those. And it's got to be E because, well, it's got to be because that's the standard deviation, and that's the mean there. Okay, so here is the least squared regression line. What is the difference between the family's actual cost and the predicted? Is to make predictions. So if we plug this in there for the number, we're going to be able to make a prediction here. So we would say the predicted cost, that little hat means predicted. Predicted cost would be negative 33.22 plus 44.77 times 135. So if you type that in your calculator, you should get the predicted cost here. By the way, I should probably read this carefully. The number of family members is what goes in that box. So I think there was 4 in this particular family. So if you put 4 in there and you type that into your calculator, you'll make the prediction of $145. Now this family only spent $135, so if you subtract those, let's see, this would be, well, I didn't type that in right. So 145.66 minus 135 would be 10.66, right? So 10.66, and is it increasing? Let's see, what is the difference between the family's actual cost and the predicted? So actual cost minus predicted, if I did that way, it actually would be a negative $10. And so I believe that would be the right answer there. Very tempting answer, D. But if you read it, what's the difference between the actual cost and the predicted? So I would do actual minus predicted, other than I did it the other way around here. I get a positive result. But if we did it in that order, I would say it's negative value here, and that's the right answer. Which of the following has a mean of 30 and a standard deviation of, so mean of 30, let's just check that out first. So mean of 30, okay, that looks okay. Mean of 30, not that one. Mean of 30, and not that one. Mean of 30, I don't think so. Okay. Standard deviation of 7. So if it looks like a normal curve, it's going, so that would be 21 units to each side. So if I added 21, that would be like 51. Let's see, if I subtracted 21 units from 30, that would be 9 or so. That's not enough here. Let's go 21 units. So that'd be like 51. That's about right. Subtract, that would be like 10-ish. Yep, this has got to be the right answer. So I do it by, I'm adding or subtracting 3 standard deviations. That includes about 99.7% if you go in both directions. Add or subtract 3 standard deviations from both directions. That's almost all of the data. Well, it looks like that's about all the data right there. That's a very nice way to mark it. And 2 manufacturers of canned goods add different amounts of vegetables. So the other mentions that. So what is the mean and standard deviation of different amounts of water added? So mean add the same way you would think they would add. So if you have a 15.25, oh wait, let's see. So we add a mean of, let's see, mean of 4.5 has a mean of 5.1. So if I add those together, that would be 9.6. So I know the mean is 9.6 right away. And then if you have 0.63 and 0.57 for standard deviations, you can't just add those guys, right? You got to go, okay, the standard deviation of, when you add standard deviation with 2 random variables, the standard deviation would be the square root of 0.63 squared plus 0.5 plus 0.57 squared. And so if you do that and type that in your calculator, I'm pretty sure that's not, so that's definitely bigger than, so let's see what happens here. Let's type it into our calculator. So if you add that, you get 0.859, so it's got to be this one, which makes me think maybe I didn't read, but actually we were doing the difference. So the difference between 4.5 and 5.1 is a difference of 0.6, so it's going to be one of these, and it's definitely answer choice B, because I know I got the standard deviation right, because I did my little method there for adding standard deviation. This last question, the correct answer is E. I don't know if I have time to go over it, but it's definitely binomial, and you might be able to work that out on your own, but the answer is B there. And I wrote down the variables off there to the right. I would use binomial CDF on my calculator, but they calculate